Alright guys, so we're going to practice this one more time, the inverse variation relationship. And it says, do the data below show inverse variation? Alright, so we're going to do that first. And then if so, write a model that gives the function. So let's just write the equation, okay? So remember, the inverse variation equation is y equals a over x, but the way we found a, that constant, was that we multiplied those two, okay? So also remember that in order to see if it's variation, you can just multiply. Okay, you can just multiply the input and the output and see if it gives you the same constant. All right, so let's just put that into our calculator. 2 times 18 is 36. So if I multiply those two, I get 36. If I multiply those two, I get 36. 6 times 6 is also 36. So far it looks right. Let's double check the decimal, just because that's not one that we know off the top of our head. 8 times 4.5 is also 36. And then 10 just moves the decimal over. So that's also 36. So since they all have the same constant, since x times y is 36, 36, 36, since this x times that y always gives us the same constant, that is an inverse variation. So, do the data show inverse? So yes, it's inverse. And then the model or the equation is pretty easy because it's just this equation, y equals our constant over x, and we just discovered that the constant is 36. It didn't matter how much x and y changed, because every time they changed, they still multiplied together to give us that 36. So there is that model that it's asking for. And then sometimes there's another question that says, well, what is y when x is, another number? And so then we would use it. But that's all that one was asking for. Okay, so now joint variation is just a little bit of a build onto direct variation. Not too bad. All right. Okay, joint variation occurs when a quantity varies directly with the product of two or more other quantities. So it's direct variation with a few more variables, okay? In the equation below, A is a non-zero constant, so A is still the constant, but then instead of just times X, it's also times Y, so two or more. So it could be X, Y, and Q, or X and Y, or it could be any combination of those. So it's very, very similar to direct, it's just there's more pieces to it, okay? So we would say it as Z varies jointly with X and Y. Okay? So whatever the multiple things that we're multiplying by are, that's what we're varying jointly with. Alright, so then we just use that relationship, we use this equation. You may want to put a cloud or a box or something around it so it's easy to see. And that's what we're going to use to answer the next questions to finish out these notes, alright? Alright, so this says the variable z varies jointly, so we know this is the equation we're going to use, with x and y. So, also, z equals negative 84 when x equals negative 4 and y equals 3. So again, just like before, we use the first set of numbers, and it's a little bit hard to see on your note, up here, but I know on your notes you can see it. So we use this first set of numbers first, then we go back and we use the other set of numbers to answer the question that it asks, okay? Or, yeah, because there's a question right here, all right? So the first set of numbers helps us write that equation. So instead of z, I'm going to put in negative 84. A is the constant, that's what we look for. Instead of x, I'm going to put in negative 4. and instead of y, I'm going to put in a 3. Okay, then we just multiply. This is negative 12. This is still negative 84. So when you divide both sides by negative 12, you get a 7. So the constant is a 7. So the joint variation equation is 7xy. Okay, so that z equals 7xy. That is the equation. 7 is the constant, no matter what anything else is. That's the constant that we just found. Then we can use the constant to answer the question. So the second part, the question says, find z when x is 5 and y is 2. So now this is part 2. This is what we do second. Okay, if we know that the equation is y equals 7x, I'm going to do this off to the side. We know that it's, z equals 7xy. Now I can answer this part of the equation. I can find z when x is 5, so I'm going to put in a 5, and when y is 2, so I'm going to put in a 2, and that will help me find z. 7 times 5 times 2. Well, I'm going to go backwards. 2 times 5 is 10, times 7 is 70. Okay, so this helps me answer this question at the end. I had to use the beginning information to set it up to then answer the question, okay? So when x is 5 and y is 2, using substitution, it's the same thing we have right here. Z equals 7x, which means that 7 times 5 times 2, and that comes out to a 70. So there's the answer to the final question, but we took it in parts. This is part 1, that's why I wrote it in pink, and then this is part 2, that's why I wrote it in blue. Okay? So that's what you use. You use the equation, find the constant, then answer the question. And that's what we've been doing with inverse as well. So you follow the same process, just a different equation as you're going. Okay? So we will practice it just a little bit more on the last page, and then we'll be squared away with this variation.